So here we are at the beginning of chapter 9. We've kind of laid the foundation for the second half of unit 7, where we've kind of talked about geology and resources that come from the earth. And now we're going to talk about how we feed a population that's over 7 billion, approaching 8 billion. We kind of have to talk about the basics of agriculture, which is going to relate to soil. And then in the next lecture, the last lecture, we're going to talk about ways that we wind up feeding the ginormous human population. So this is the underpinnings of agriculture. This is what we're going to talk about. We're going to look at soil properties, how we irrigate crops, the importance of pollinators, and issues that we have with the way we do agriculture, and then policy, of course, because, we have to talk about policy. Agriculture is really important. There's a Captain Obvious statement. Agriculture is related to everything, to feed us, to clothe us. So it's really important. But on the other hand, some of the practices that we do are related to agriculture are some of the most damaging things environmentally. They have the biggest impact, negative impact. So agriculture by definition is raising crops and livestock for us to use and to consume. We can look at the land that we use for that in two ways. Cropland is land that you use to raise crops for us to use. Rangeland or pasture land is where we graze our livestock. We need resources to do it. Soil, sunlight, water, nutrients, pollinators. And a third of the acreage on the planet is used to produce food and fiber. So it's a big chunk of our planet that we use to take care of humanity. So how did it start? Climate started to warm about 10,000 years ago, and we moved away from the hunter-gatherer lifestyle to a permanent settlement with farming. So we developed little villages, we cultivated crops, and it started out traditionally with wild stuff. And then we were able to choose different crops based on season for what would grow better. And we kind of started the whole idea of selective breeding. So we look at agriculture in one of two ways. Okay, we can look at traditional agriculture or subsistence farming. So you have enough livestock and you have enough cropland and other agricultural things to take care of only your family. It's called subsistence farming, right? So you had enough for you, and your neighbor had a little plot and a cow and some chickens, and then all of the neighbors around you did. Okay, so you were able to take care of yourselves. In industrialized agriculture, which is what's happening now, farmers farm huge swaths of land to feed lots and lots of people. We're not all farmers anymore, so we have to rely on other people to feed us. And that's the idea of industrial agriculture. When we get into industrial agriculture rather than subsistence or traditional agriculture, we're using, the combines and all of these big pieces of equipment and machinery, which increases our fossil fuel consumption to feed the masses. When we do that, we have to irrigate more. We wind up using synthetic fertilizers and pesticides to get rid of crops and weeds to increase our yield. So this is an industry now rather than, just basically taking care of your family. When we get into industrialized agriculture, we talk about something called monoculture. And if you look at the fields around here in the spring and in the summer and in the fall, you have fields and fields and fields of one crop. All fields of corn or fields of sorghum or fields of soybeans. Okay. That's monoculture. Mono is one. Okay. And it's in orderly rows for as far as the eye can see. Traditionally, and if you think about your gardens at home, you don't just plant corn. You'll plant a couple rows of corn and a couple rows of tomatoes and a couple rows of zucchini and some cucumbers and all this other stuff. That's called polyculture. And it's in the same field. You don't have a whole field of corn and then a whole field of zucchini. Right? Polyculture is when you put mixed crops in the same field. And that's if you can think of a bigger version of your home garden plot. That's polyculture. We're going to talk about the Green Revolution in the next chapter. But in the 1950s, actually 1950, a guy named Norman Borlaug developed something called the Green Revolution. And again, we're going to talk about it in more detail in the next chapter. We had more technology, crop varieties, and farming practices were introduced into the developing world, which really reduced food insecurity for a lot of people in the developing world. Okay, so they have bigger yields, more food, but the downside of that is that we've had issues with water supply, soil quality, and the presence of pollinators. So again, it's a cost-benefit analysis. It's a trade-off. We're not starving, but what are the environmental impacts? So we've gone back to this idea of sustainability again and again and again throughout this course. So it's no surprise that we're here. Okay. So if we look at sustainable agriculture, it's a way to balance all of the factors that are super essential in agriculture. So you have healthy soil, clean water, you keep your pollinators, and all of the other little pieces that you need in order to let agriculture be successful. And which, as is the case with most of this idea of sustainability, we want to mimic the way natural ecosystems function. Okay, natural ecosystems function in a sustainable way. They just perpetuate, they keep going on forever in terms of nutrient cycling and all that stuff. So we're trying to do that. It's the smartest thing to do. In order to do that, we need to understand soil, water, nutrients, and pollinators. We need to understand those underpinnings of agriculture and how they work together to make agriculture possible. So if we look at soil, okay, it's not dirt, it's soil, okay, because it's more than just, dirt is like what you get on your clothes, right? Soil is rock, organic matter, water, gases, nutrients, and critters. There are organisms in soil, okay? Soil comes from rock, but it's shaped by microorganisms. So the things that are in the soil, the worms, the slugs, all that lovely stuff, are important for the health of the soil. All right. So if you take a volume of soil, about half of it is mineral matter. So it's based in rocks, 5% is organic matter, and the rest of it is pore space. There's space in between the mineral matter in soil that's really, really important for the health of the soil. So the structure of the soil and the quality of the soil will determine the success of your agriculture. Okay. So the plants need to be able to root. So there's got to be enough there, enough material to root into. The organic matter is important to provide nutrients and to hold on to moisture, which the plants need. The nutrients that are in the soil, like the nitrates and the phosphates, okay, really allow the plants to grow. As you look at the structure of the soil, that will determine how the roots are going to grow and how much water is going to be retained. And then you need soil that's going to retain water, but not hold too much water. All right, to allow the roots to get water, but not to drown. So it's kind of a complex situation, and you guys thought it was just dirt. There's lots of organisms in the soil that help to keep the soil healthy. Fungi, bacteria, that kind of thing. So we've talked about soil as a natural resource. Soil is a renewable resource. It starts to form during primary succession. So if we throw way back to one of our early units, you have land where there was no land before, and you have those pioneer species like lichens, and then the physical weathering of water and air to kind of break down that parent material into preliminary soil. So what a parent material is the geologic material in a location. So it's sediment, it's dunes, it's hardened lava or volcanic ash, or it's bedrock, which is the mass of solid rock that makes up most of the Earth's crust. When you look at geologic maps of the United States or New Jersey or an area in particular, what you see there is the bedrock, what the bedrock is made out of. That parent material gets broken down into smaller pieces by a process called weathering. All right. So there's 3 kinds of weathering. Physical weathering comes from wind, rain, freezing, and thawing. You guys know, around this time of the year, it seems like potholes appear from nothing. So we're at a time of the year, spring is like this, where during the day, the temperatures are warm. So anything that's frozen is going to melt. And then at night, the temperatures get cold, so it freezes. We know that ice expands, water expands when it freezes to become ice. So the water that's down in the cracks in the road is going to expand when it freezes, right? And then when it thaws, it's going to shrink, and it's going to freeze and thaw and freeze and thaw. And then that breaks the road apart to make potholes. Well, the same thing happens with rocks, okay? Wind will pelt it, rain will pelt it, and then the freezing and thawing will cause cracking. Chemical weathering happens when water or gases chemically alter rock. So when we looked at acid mine drainage, the orange that's left behind is considered chemical weathering. We've also seen chemical weathering when we look at the headstones at the Rosemont Cemetery, the limestone headstones. They degrade because of the acidic precipitation. Biological weathering happens when living things alter the rock. So tree roots rub against the rock to wear it away. Lichens are really important in terms of soil formation because they produce acid that breaks down the rock and into its components. So biological activity keeps happening even as the soil is formed already. So you have decomposition or waste that's in the soil, right? So we leave leaf litter down to let the bacteria and the worms and stuff decompose it to enrich the soil. What that winds up as, okay, is something called humus. It's not hummus. Hummus is 2 M's. This is humus, right? It's not a chickpea paste. It's humus, right? So humus is kind of like compost. So it's partially decomposed organic matter. It's really rich in nutrients, and it's really important for plant life and crops to grow. So weathering and the accumulation of humus in soil is dependent on a bunch of stuff. So if you have a warm climate, weathering is going to happen faster, especially if there's a lot of moisture in the air. If you have a lot of organisms in the area, you're going to have decomposers adding organic material. If you have a hilly area, right, you're going to have more soil formation at the tops of hills, right, rather than at the bottom, because the tops of the hills are exposed to sun and moisture and wind. So that's going to move soil. Depending on the bedrock that you have, the composition of the bedrock is going to determine the kind of soil that you get, and time. If you take all of these pieces together and add in time, that will determine how long it takes the soil to form. So, like I said, soil is renewable, but it's renewable at a very slow rate. So if you look at a cross section of like a slab of earth, what you see are layers, right? That cross section is called a soil profile. And the soil, as you look at that profile, you see distinct layers, and those are called horizons, okay? the degree of weathering and organic matter decreases as you go from the top to the bottom, right, of a soil profile. And that makes sense because all of the living things are going to be at the top, or the vast majority of living things are going to be at the top of the soil profile. And as you get down closer to the bedrock, there's not going to be much living. So there's not going to be much organic material in there. Minerals and dissolved substances are suspended in water, and they wind up getting transported down as water percolates through in a process called leaching. And we're going to take a look at a soil profile. Okay. So one thing you guys are going to have to know is the order of these soil horizons. O, A, E, B, C, R. I didn't make it up. So if it was up to me, it would be in alphabetical order, but it's not. So O is the organic litter layer. So it's what's at the top. Leaf litter, when you're walking through the woodlot or walking through the woods, it's what's sitting on top. Below that is the topsoil. Topsoil is a combination of mineral matter and organic material. So this is the kind of stuff that you need to have to grow grass or crops or anything like that. You need a good topsoil layer. The alluviated layer or the leaching layer loses a lot of those minerals as the water percolates through, and it makes its way down into the subsoil, which is the B horizon. The C horizon is the transition between the original parent material, which is the R horizon or the bedrock, and the subsoil, right? As it starts to weather a little bit, you're going to get the C horizon. So make sure you guys know the order of these things and what they are and what's going on there. Different soils have different qualities. So if you look at a soil profile, you'll see the differences if you look at them from different areas. So a soil's color indicates its fertility. So black or dark brown soils are really rich in organic matter. The lighter the soil, the lower the amount of organic matter in it. And the texture of a soil is determined by the size of its particles. Okay, this is a really important diagram. So it's something that we are definitely going to talk about when we talk about our key points. And I have an exercise that I'm going to put together for you guys to teach you how to read it. This is called the soil triangle. I've seen lots of questions on interpreting the soil triangle. If you look at the pictures around the soil triangle on the outside, there's three sizes of material that you can have in soil. Clay is the smallest, right? It's got particles less than 0.002 of a millimeter in diameter. This is really teeny tiny stuff, all right? Silt is the intermediate size, between 0.002 and 0.05 of a millimeter in diameter. And then sand is the biggest. Sand is from 0.05 of a millimeter to 2 millimeters in diameter. So those are your three sizes. A term that you're going to have to get accustomed to, if you have a soil with an even mixture of each particle of sand, silt, and clay, it's called a loam. All right. And loams are really good soil for agriculture. And we'll talk about why. Clay is not really a good soil to have for agriculture. There aren't many pore spaces, so that's the spaces between the grains. And the clay particles themselves are sticky, so they stick together. So water doesn't pass through very well, and air doesn't pass through very well. So that means that anything planted in clay is not really going to survive well. And you guys know, like, I look at my front yard, and the first acre of my yard is wetlands because we have really clayey soil. If you guys have an area of your yard that pretty much stays wet, it takes a really long time for it to dry out. Chances are there's a lot of clay. And based on the rock around here, it kind of makes sense. A sandy soil, you don't want your soil too sandy because then water passes through too quickly, which requires a lot of irrigation, which causes some environmental issues. Loam that has medium-sized pores is probably the best for agriculture. And we'll talk about porosity and permeability when we talk about the key points. Structure also measures the clumpiness of the soil, right? You don't want soil that's really clumpy because it doesn't absorb water as well. And again, if we talk about pH, we want it somewhere in the middle pH, like a neutral-ish pH. And if the soil is too acidic or if the soil is too basic, we can do things to improve that. And we can talk about that when we talk about agricultural methods. So here's what I was talking about before. If you look at the cross sections of the soil profiles, this is one for the Amazon, right? Somewhere in the rainforest. It's a light color. So this is really low in nutrients. So when they do that slash and burn agriculture, they're trying to enrich. Ash is very enriching for soil, like volcanic ash and ash from fire. So they try to enrich it in order to make agriculture happen. Whereas something in Iowa or Kansas, this is like beautiful in terms of soil profile, right? Here is your topsoil, right? And it gets lighter as you go down. But this is where your agriculture is going to take place, in this top layer. So in that case, it's perfect. In the tropics, they do something called swidden agriculture. So they will work on a plot for a few years until the nutrient levels get sucked out, and then they'll move on to someplace else. And if they allow it, the forest can recover, and then they can come back and do some more agriculture there. They do the slash and burn agriculture, which you can see. It's literally they slash the trees and burn it as a way to enrich the soil. Irrigation is a huge thing that we have to talk about. So if we add water to our crops more than what precipitation can provide, we call it irrigation. All right. So irrigation is the biggest use of all water that we use when we use fresh water. It takes up 70% of the fresh water that we use. It's really necessary for water intensive crops like rice, but it's also really necessary in places with dry climates. So this is the Southern California desert. It's all red, right? Except for this green. And this is what they call center pivot irrigation. So there's a kind of like a framework that's hooked to a water supply here, and it moves around, right? So it's kind of like the hands of a clock, and it winds up moving around to keep whatever crop this is green. Another method of irrigation is called flood and furrow. So they have these ditches in the field, and they fill it with water, and then it gets absorbed by the plants. It's not very efficient, and we're going to talk about irrigation methods in a minute, like right now. I didn't make this, but it's really, really good, so I stuck it in here. So flood irrigation, right? The College Board needs you guys to understand different irrigation methods and pros and cons. So the pluses are there with the blue plus, and the minuses are there with the red minus. So flood irrigation is essentially what it sounds like, just flooding a field of water with water. It's inexpensive, right? You just have hoses and you flood the field, and it's really easy to do. But when you do that, about 20% of the water in flood irrigation is lost to evaporation and runoff, okay? Which is a waste of water. And the soil gets waterlogged. You have way more than what you need. And when the soil gets waterlogged, like, it can kill the roots of the plants because you wind up not allowing enough air to get to those roots. And there's an example. Furrow irrigation, and we kind of talked about this. You cut furrows or little ditches between the crops, and you fill them with water. It's not very expensive, but again, a lot of it is lost to water evaporation or runoff. So it's not very efficient. And there's a picture. Spray irrigation is, a possibility. And that's what you see in the center pivot irrigation. So you have pumps that pump up groundwater into a nozzle, and then it covers the agricultural field. Sometimes it's center pivot. I've also seen it in the fields in Delaware on my way to Ocean City, Maryland, where it's just like this thing that you see here is on wheels, and it just moves back and forth across the field, not necessarily in a circular pattern. It's more efficient than flood and furrow, okay? Because you can control how much water goes in, right? And you can only water when you need to. And one perk is that there's less water that is lost to evaporation or runoff. So it's about a quarter rather than a third or more. Two problems with it. It's more expensive because you have to have the infrastructure, right? The equipment to make it happen. And it requires energy to run. This thing has to move around the field or back and forth across the field. So it's going to require energy, usually in the form of fossil fuels. Drip irrigation. Okay, this is the most efficient. So you've got hoses along the crops, and there are holes in those hoses. And when you turn the drip irrigation system on, that water drips in really small amounts onto the roots themselves. It doesn't spray the whole plant. It doesn't, waterlog the soil. It's just little tiny drips onto the roots. It is the most efficient of all of them, which is a fabulous thing. And only about 5% of the water that comes out is lost to evaporation and runoff. So we're using a lot less water and getting the same result. In some cases, a better result, but it's really expensive. You have to have this system of hoses set up all throughout your fields. It takes a lot of initial investment. So it's not really often used, but it's the best method that you can you can use to irrigate your crops in terms of water use. Something that happens when we look at the flood and furrow and then the general field flood irrigation is waterlogging, right? And we kind of mentioned it before. There's too much water left to sit in the soil, all right? So if there's water sitting in the soil, the water table, like we talked about in a previous chapter, in chapter 15, is going to rise, okay? So the water is going to remain in the soil, and it's going to make it difficult for the roots of the plants to get oxygen. So they wind up dying. Even the roots need oxygen. So waterlogging is not a good thing. Something else that happens is something called salinization. Groundwater has natural minerals in it. If you overwater, what winds up happening is that the salts in that groundwater that you use to irrigate will remain in the soil after the water evaporates. Okay, so too much of that salt that winds up in the soil can actually be toxic to plants over time. So that's why you kind of have to be careful with your irrigation and even watering your houseplants too. Okay, so this talks about salinization again and waterlogging. The issue to resolve the idea of salinization is to flush the land, like essentially rinse the land with fresher water, right? With less minerals in it, or to plant a salt-tolerant plant like barley to let that absorb those salts. So it's like a crop rotation thing, which we're going to talk about. There are solutions, though. Something else we can talk about. We talked about the Ogallala Aquifer when we talked about it. It's one of my favorite environmental science names. We can wind up depleting aquifers if we use fresh water too much for irrigation, right? And that's something that we kind of have to be aware of. And we talked about it before. So there's the Ogallala Aquifer. It's huge, right? And you can look at the changes in the thickness of the aquifer, right? Where the water table is over the course of time. So we have some spots that are more than 150 feet lower than what they were, especially down in like North Texas. in southern Kansas and even into the Oklahoma Panhandle. There are places where it's actually thickening, right, in southern Nebraska. All right. But for the most part, most of the colors that you see here are in the declining water level change. And that's going to cause issues for the people living there in terms of their water use for at home and consumption rather than just for agriculture. So there's definitely a benefit to using irrigation methods that are going to use less fresh water. And we kind of talked about this when we talked about it, the groundwater thing. So how do we do sustainable agriculture? One really good thing to do is to use to plant crops that better match the climate. So we talked about almonds in California. Almonds require a lot of water. Most of the almonds in the world are grown in California, which is a dry, arid state. So if you're going to do sustainable agriculture, you don't grow water-loving crops in an area that doesn't have a lot of water, right? So you're a little more cognizant of the match between climate and the crops that you're planting there. And improving irrigation methods is another way to improve agriculture, to make it more sustainable. When we talk about nutrients for plants, there are two basic kinds of fertilizers. An inorganic fertilizer, right, is one that's mined or synthetically manufactured. We briefly talked about the Haber-Bosch process when we talked about the nitrogen cycle. Not something that's testable, but that's the way that you enrich fertilizers in nitrogen. All right. So that's one thing you can do. So in those nitrate and phosphate, we talked in the mining chapter about mining nitrates and phosphates. You can do that and synthetically create fertilizers. Organic fertilizers, compost, right? Crop residue, manure, all that kind of stuff. It provides the nutrients, but it's not synthetic. And that's what compost is. If you guys have a compost bin in your yard or a compost pile in your yard, you take, the vegetable scraps, grass clippings, that kind of thing, mix it all together, some bacteria, some thyme, give it a couple flips or stirs, depending on whether it's a barrel or a pile. And you wind up with great stuff to put in your garden. Since the Green Revolution, and one of the things about the Green Revolution that's the downside of it, we've moved away from organic fertilizers and moved into using inorganic fertilizers. So this is where eutrophication comes from. The nutrients get leached, they don't get absorbed, and then you get other environmental issues. And you can look at how the trend in terms of millions of metric tons a year, we're almost at 200 million metric tons of inorganic fertilizer a year. That's got to cause problems with water supply. And as if I knew what was coming, which I did, here's eutrophication. We don't have to go back to eutrophication because we understand eutrophication. This is causing the dead zone in the Gulf of Mexico. This is causing the dead zone in Chesapeake Bay. Here it is. You can have it going into the air and making our NOxes, which is contributing to photochemical smog and acid deposition. Who'd have thought that? Okay, so we need fertilizer. We want our crops to grow. We need to feed 7 billion people. How can we do it, right? So if you use drip irrigation, you can infuse fertilizer into that irrigation. So you're only using a little bit of fertilizer right at the plant root. Another thing that you can do is something called precision agriculture. So you're constantly monitoring nutrient levels in the soil and only applying fertilizer when you need it. Not, the crops have been in the ground for 6 weeks. Now is when I have always applied fertilizer. So I'm going to go and spread fertilizer all over my crops. No, you look at the soil quality and then you make a decision. Do you do it now? What kind do you put down, right? Instead of just doing what you've always done. You can, in sustainable agriculture, we tend to use more organic fertilizers rather than inorganic fertilizers, but doesn't matter whether you use an organic fertilizer or an inorganic fertilizer. If you use too much, you're going to wind up with nutrient runoff and potential eutrophication. So organic fertilizer is good, especially if you are careful with the amount you use. All right, pollination. We know what pollination is. It's taking the pollen and getting it to the female parts, which I can't remember. Oh my gosh. The pistil. That's what it is. There are a bunch of ways that plants can be pollinated. Grasses and trees are pollinated by wind. We are getting to allergy season. So we're getting to that point where we're going to have issues with it. So as the wind picks up, depending on, what's blooming, our allergies are going to wind up kicking up. Plants that have really bright flowers are going to attract animals. Those are the pollinators, which are going to transfer pollen as they move from flower to flower, like bees and hummingbirds and that kind of thing. Lots of crops rely on pollination. Most of the crops that we use, most of the crops that we have access to on a regular basis, we need and eat on a regular basis, are going to be pollinated by pollinators. Grain, like wheat and corn, are wind pollinated. Fruits, vegetables, and nuts require insects. All right. Most are pollinated by bees. And the European honeybee is so essential for the success of a field or a crop that many farmers are going to hire beekeepers to bring in hives during a pollination season, right? And there are people who do that on a regular basis. In the 1950s, we wound up using lots of plowing and lots of pesticide and wound up killing a lot of soil-dwelling bees. So what happened was that, you don't have pollinators. So they wound up transplanting soil with bee larvae to help with that. Currently, honeybees are definitely on the decline. I know that walking from my house to my neighbor's house when I was a kid, the grass was all full of clover. And I had to be really careful where I walked so I didn't step on a honeybee. Now, Aaron can go outside once our yard pops with clover, and we don't see a bee at all. It's much more uncommon to see a bee than it was when I was a kid, 30, 40 years ago. That's happening due to pesticide use and habitat loss. They've got no place to live. So there's no place for them to live. And then the pesticides that we wind up using kill the pests that impede productivity, but they also kill the things that we need. There's issues, okay? Those key resources for agriculture: soil, water, nutrients, and pollinators are dwindling. We have issues with each of them, and we can't. We need these things. We need to do something to preserve these things. So how is soil getting degraded? So land degradation is when land gets so diminished in terms of productivity and biodiversity that the whole ecosystem won't function. Okay, that's going to result in more soil erosion, nutrient depletion, water scarcity, and pollution. As the soil degrades, right, the land might not degrade, but the soil itself could degrade. So you're going to have worse quality, right, in terms of nutrient components and all that kind of thing. And that happens when you get rid of the forest, right, because that's a main supply of nutrients. If you have huge amounts of monoculture, right, you're not putting nutrients back into the soil. And if you let livestock overgraze rangeland, you're going to have poor soil left behind, which is going to cause an issue. Okay, this is degraded soil, right? If you think back to the picture that we saw in Iowa, that soil was really brown and really rich. This is very degraded soil. There's not much organic material in there. If we don't do something about it, right, we've reduced soil quality significantly in some areas. So if we take that, coupled with the fact that our population is increasing, we may have a hard time feeding the world in the future. We talked about erosion. Okay, so erosion is when we talked about the forest. Erosion is when material gets picked up from where it is and gets transported someplace else. When eroded material is dropped off somewhere else, it's called deposition, and that's how sedimentary rocks form, like we talked about in chapter 2. Erosion and deposition are natural, right? Wind and water are naturally going to erode and deposit soil. But because of how we're doing agriculture, it's happening at a much faster pace. So topsoil is going to wind up disappearing. Areas that are windy, sloped, have a lot of precipitation or don't have much vegetation covering them are at the highest risk for erosion. And that kind of makes sense based on like your existence on the planet. If you overcultivate a field, right, if you're not careful with it, you're going to make erosion happen. If you graze rangeland with more livestock than it can support, you don't let the grass and stuff grow back, you're going to be more susceptible to erosion. If you clear forests, right, clear cutting forest, especially on a slope, is going to increase erosion. We're losing an inch of topsoil every 15 to 30 years. And in some cases, it takes 1,500 years to grow. I'm going to use that for a term, to create an inch of topsoil. So it's not working out well. We're definitely losing topsoil. And it's not just in the United States, it's across the entire planet. All right. So it's not just an us thing. Something that happens is related to soil is desertification. Okay. A lot of the world's population lives in dry lands that are arid and semi-arid. If you are doing agriculture in a bad way, that land is more susceptible to desertification. So desertification means turning to desert, where the productivity of the land gets lost. So once fertile areas are going to turn to desert as the result of wind and water erosion for the most part, as you can see from the pie chart. This is a crazy picture, right? This is the Gobi Desert over in China. Desertification, basically not taking care of land, is causing the desert to expand. So it buries villages, it destroys agricultural land, and it forces farmers and ranchers to use lower quality land. So then it degrades faster. It's that positive feedback loop. This is crazy. This picture just wows me every time I see it. We're going to talk about the Dust Bowl in our key points. It's just a neat thing to think about. It was a really, really sad thing, but in terms of U.S. history, but it's a neat environmental disaster to talk about. Late 18th and late 19th, and early 20th centuries, people moved to the Western Plains. They plowed up native grasslands and planted lots of wheat. So in the 1930s, there was a lot of drought. Okay, there was a huge drought that made the monoculture that you saw when they pulled up the grasslands and planted the wheat made it even worse. So the soil is dry. It's not being held in place by well-developed root systems of the native grassland plants. So the soil essentially blew away. Some areas lost up to 4 inches of topsoil. Okay. And this was the Dust Bowl, right? So it's in this area that you can see. And dust storms were like this, just kind of crazy. And thousands of farmers were forced off their land. Farmers weren't able to take care of their families, so they would sell their children. It was just awful. Ken Burns did a really good miniseries on the Dust Bowl. So if you guys are interested in it, I would recommend you watch it. So to prevent that from happening again, we legislated. So they passed the Soil Conservation Act of 1935. It's now called the Natural Resources Conservation Service. And there's a soil conservation district over on Pittstown Road that if you're going to do any building or if you're dealing with agricultural issues, you have to have them come in and give you their opinion. So how can we conserve soil? Since the Dust Bowl, one thing that we do is we rotate crops. So the field by my house one year might be corn. The next year they might plant soybeans. So you alternate crops from one season to the next. That helps to improve soil quality. And it also helps to break the pest cycles, right? And disease cycles that you see when you plant the same crops in the field, the same field year after year. The pests and the disease have nothing to feed off of, so you wind up reducing their impact. Another thing that they do is contour farming. So that's used in a lot of cases in hilly regions. So instead of plowing down the hill, right, and basically making channels for the water to run right down, so you have soil erosion and water logging and all that stuff, they kind of make it a bullseye. So the furrows, the rows that they plant, are perpendicular to the hill rather than parallel, so it prevents the water from flowing downhill. So it looks kind of cool. In mountainous areas, right, so this is probably China, they terrace the fields, right? So these are like steps. If you could picture like just wide steps, giant size steps, just walking down the steps. So this is a flat area cut into the side of a mountain. You can see it right here. It's a lot better than, just having these contoured fields, because the hills are a lot steeper and you're going to wind up having erosion just running down these hills if you did it any differently. Something else that you can do is called intercropping. So you plant, beans and then tomatoes and then maybe zucchini. So you have different bands of crops. So those are good. Doing that is good because, first of all, it's polyculture, not monoculture. And second of all, you, depending on what you plant, it can help enrich the soil. If you're not interested in planting huge swaths of different crops, you can plant something called cover crops. When you plant cover crops, it prevents wind erosion, right? So it keeps the soil in place, even though it's not necessarily something that you would grow and profit from or eat. Something else that they do around here, when they cut out fields for agriculture, they tend to have shelter belts. So rows of trees or shrubs, it's like a tree line, that keep the wind from blowing too hard across too big of an area and then eroding soil. And what you plant in between, or what exists in between, is good natural habitat. Something else that they do to conserve soil is what they call conservation tillage. So they don't plow as often. And then plowing leaves the surface soil bare, so they won't do it as often. So you get less erosion by wind. Or you can do something called no-till farming, where they don't turn it over at all. So what they'll do is they'll leave the crop residues, whatever, bean stalks or corn stalks are left behind from the previous year. And they'll just plant right in it. to prevent soil erosion. And I talked about cover crops. You can plant cover crops in an area when the field isn't growing. You're not planting a cash crop or a profit crop. Depending on how you graze, that can affect soil quality too. There's lots of livestock on rangeland around the planet, and if you do it smart, you do it in a smart way with smart methods, and you rotate your rangelands, right? So you don't have all of your animals grazing in one area at the same time. You can allow that rangeland to function as a natural ecosystem. If you don't, you get overgrazing. And this, you can see in this picture, is definitely overgrazed land. Not much for these goats to eat out there. You wind up with a positive feedback loop. If you overgraze, and then it's just going to degrade the soil altogether, and you're not going to have much good stuff growing there. We wind up with policy, okay? Policy is one of the ways that we can promote conservation measures. So we can subsidize farms to help, okay? Subsidies traditionally is how we've done it, but they keep the farmer's income stable and secure, which is a good thing. But that forces the farmers, it gives the farmers incentive to go in and cultivate land that shouldn't be or wouldn't otherwise be cultivated. So that's not necessarily a good thing. So one thing that has happened, regardless of, which administration is in the White House, we tend to look at this at legislation every 5 or 6 years to kind of see what's going on. Something that came out in 1985 was the Conservation Reserve Program, which paid farmers to convert damaged cropland to conservation reserves. So if this is cropland that's not usable anymore, you let it be and you let it go natural. And if you do that, then the federal government will pay you. So internationally, okay, the UN promotes the Food and Agriculture Organization to help achieve a lot of the goals that we try to do here in the US. We try to allow farmers to do their thing in a way that's not going to do more environmental harm and damage. So that's the basics of agriculture. And now you guys are going to move right into what we actually do to feed the huge human population.